Very good morning to all of you. I am Krishna Nagai, your maths teacher, and today we are going to start second part of our first chapter, that is rational numbers. Earlier we have studied about the closure property. Now we will continue with the next property, that is commutativity. Now, what is the commutativity means? Exactly, if we can say that if any two numbers are being operated in any sequence, then these will be equal. This is how we define the commutativity. Or in a simple language, we can say that if a number A is operated by any other number B, then the result would be same if we operate B by the same operation to A. Now, what are operations? We know that there are four basic operations, that is addition, subtraction, multiplication and division. Now, let's understand with some examples how it actually works. If we operate, means that if we add, subtract, multiply or divide any two numbers, say 2 plus 3, then the result of 2 plus 3 is 5, right? And if we operate 3 plus 2, the result is also again 5. So we can say that 2 plus 3 is equal to 3 plus 2. It means that the numbers are following commutativity for the operation addition. Similarly, if we check for the second operation, say subtraction. Suppose I subtract 3 from 5, it would result 2. But if I subtract 5 from 3, then the result would be minus 2. Here you can see that the results are not same. So we can say that the commutativity is not followed by the numbers for operation subtraction. So this is how the commutativity works. It means that if we operate any two number in any two sequence, then the results are same. Let's check for division also. Say 3 divided by 2. The result would be 3 by 2. But if we divide 2 by 3, then the result would be 2 by 3. And we know that 3 by 2 is not equal to 2 by 3. So we can say that these numbers doesn't follow commutativity for subtraction. So let's check this property for various numbers. Begins with whole numbers. We know that whole numbers starts from 0, 1, 2, 3 and so on. Okay, so these are the whole numbers. So let's see whether the addition is commutative for whole numbers or not. We can easily see that if we add any two whole number in any sequence, the result would always be same. Suppose we add 0 and 7, or 7 or 0, the result would be 7. Similarly, if we add 3 in 2 or 2 in 3, the result would be same. So for any two whole numbers a and b, a plus b is always equal to b plus a. So we can say that addition is commutative for whole numbers. As we discussed for subtraction, so for any two whole numbers, a minus b is not equal to b minus a. So subtraction is not commutative. For multiplication, so if we multiply any two whole numbers, it always results the same without considering their sequence. So multiplication is a commutative property. Now division, as we already discussed that A divided by B is not equal to B divided by A. So we can say that division is not commutative. Let's check for integers. Now, you know what are the integers? All the positive, 0 and negative whole numbers are included in integers. Now, for addition, if we add any two integer, then the result would be same. If we add A to B or B to A, the result will remain same. So we can say that addition is commutative. But for subtraction, it's not true. So subtraction is not commutative. For multiplication, again, it is true. If we multiply any two integers, say 2 into minus 3 or minus 3 into 2, the result will remain same. So multiplication is commutative for integers. Now division is not commutative for integers. We know that all the whole numbers are included in integers, so those properties which are not applicable for whole numbers will not work on integer also. Okay, now let's discuss all this in detail for rational numbers. Now you know rational numbers are the numbers which can be written in the form of p by q are called rational numbers. Now for addition, for doing this you must know how to take LCM and how to add the rational numbers, and we have learned this thing in our previous classes. So how to add these two numbers? Say minus 2 by 3 and plus 5 by 7. For adding them, 3 plus, we have to take LCM of 3 and 7, that is 21. Okay, so 21 after taking LCM, the result is, we can solve it here. So 21 is the LCM, so we have to multiply 2 by 7 and 5 by 3, that would result 15. So it would result 1 upon 21, that is here. Okay, similarly we can add. Now what we are doing, we are changing the sequence. Here we have added to 5 by 7 to the minus 2 by 3. Now we are adding minus 2 by 3 to 5 by 7. We have changed the sequence, but the result is same. So we can say that rational numbers follows commutativity for addition. You can also check these numbers and you will find that the result is always equal. So again we can check for this example and we will find that this would also be equal. So you can say that two rational numbers can be added in any order, or we say that addition is commutative for rational numbers. That is, for any two rational numbers a and b, a plus b is always equal to b plus a. Now let's check for subtraction. Here you can see that 5 by 4 is subtracted from 2 by 3 and 2 by 3 is subtracted for 5 by 4. Is both of them will be equal? Let's check. 2 by 3 minus 5 by 4. We will take LCM, that is 12. Now it would be 8 minus 15, right? 8 minus 15. So the answer is minus 7 by 12. And if we subtract, if we take the RHS, then again LCM is 12 and it would be 15 minus 8 and answer would be 7 by 12. Now we can easily see that these are not equal. So we can say that subtraction is not commutative for rational numbers. Now multiplication. If we multiply 7 by 3 to 6 by 5, the result would be minus 42 upon 15. Similarly, if we multiply 6 by 5 to minus 7 by 3, again the result would be same, right? we can say that the multiplication is commutative for rational numbers, or in general we say that a multiplied by b is equal to b multiplied by b multiplied by a for any two rational numbers a and b. Division. Now we already discussed that division is not commutative for whole numbers and integers, so it is simple that the division will not be commutative for rational numbers also. So division is not commutative for rational numbers. Now we have learned the commutativity for various numbers. We can easily fill this table. Rational numbers, for addition they are commutative. For subtraction, are they commutative? No. For multiplication, yes. For division, no. So integers, yes, they are commutative for addition. Whole numbers, yes, they are commutative for addition. Natural numbers, yes. For subtraction, are they commutative? No. None of them are commutative for subtraction. For multiplication, yes. For whole numbers and natural numbers too, multiplication is also commutative. For division, neither in integers, neither in whole numbers or natural numbers, they are not commutative for these operations, for division. Now after this, let's discuss the next property, that is associativity. Now it states that if we operate any three numbers, then if we change the association, that means if we operate first two numbers, then the other two numbers, the result remains same. Or we can say, suppose for addition, say 2 plus 3 plus 4. Now how we are adding these numbers? Either we add 2 plus 3, that is 5, plus 4 is equal to 9, or we can say, if the other way would be 2, 3 plus 4, 7, 7 plus 2, 9. So we associate two numbers and then we operate with the third number. If the result is same, then we say that these particular numbers follows associativity for that operation. Okay, now let's check it. Let's discuss for the whole numbers. For addition is associative, right? So addition, if we add any two, so we can say that if we add a plus b plus c, it would be equal to a plus b plus c for all whole numbers. For subtraction, is it associative? No. Why? Because we know that a minus b minus c, if we are putting an bracket over there, then this would not be equal to a minus b minus c. This we have already discussed in our previous classes, right? Now multiplication, yes, multiplication is associative. If we change the sequence or we multiply any two numbers, then with the third number, the result remains always same. And for division is not associative, neither for whole numbers and neither for integers. Now the same thing, addition is associative for integers, subtraction is not associative for integers, multiplication is again associative for integers too, and for division is not associative for integers. Now let's discuss all these in detail for rational numbers. Addition we have already discussed. Now we know that how to add that rational number, so we can easily see that if these three numbers are given to us and the bracket is here, so we will add first these two numbers, 3 by 5 plus minus by 6. So it would result 7 by minus 7 by 30. Now we will add minus 2 by 3 and minus 7 by 30. The answer is minus 27 upon 30, which could be written in the simple form as minus 9 by 10. Now, if we operate first two numbers first, that means minus 3 by 2 plus 3 by 5. So, the result is minus 1 upon 15, and then we will add minus 5 by 6 to this. So, it would result minus 27 upon 30, and in the simple form, it is minus 9 upon 10. Here, we can easily see that both the results are same. So, these two are same. This results that the rational numbers are associative for addition. What it says, addition is associative for rational numbers, that is for any three rational numbers, they follow this sequence. They result same irrespective of their sequence. Now for addition, is this would be equal? Yes or no? No. Why? Let's solve it. Taking LHS, first we will operate these two numbers. So minus 2 by 3 minus, the LCM would be 10. Okay, so minus 8 minus 5. Okay, so minus 22 upon 3 minus, now minus 8 and minus 5, minus 13, and minus minus plus, that is 13 upon 10. Again we will take LCM, that is 30, and minus 20 plus 39. So answer is minus plus 19 upon 30. Similarly, we will solve RHS. Again, we will take LCM for first two numbers, right? So 3 and 5, that is 15. And it would be 10 plus 12 and minus 1 by 2. So it is 22 upon 15 minus 1 upon 2. Again we are going to take LCM, that is 30, and it would be 44 minus 15. So the answer is 14 minus 5, that is 9, and 3 minus 1, that is 2. So 29 upon 30, and we can easily see that both the results are not equal. So we can say that for rational numbers, subtraction is not associative. Now for multiplication. Now multiplication, we know that it sequence doesn't affect the result. So both the numbers would be same. Both the results would be same. So we can say that the multiplication is associative for rational number, that is for any three rational number, they follow this sequence. That means they the result is always same if we multiply A multiplied by B into C, or A into B multiplied by C. Now for division, so again for division we can easily solve this and check that they are not equal, right? So now we can complete this table which we have done yet. So for addition, rational numbers are associative. For subtraction, they are not. For multiplication, they are associative. Integers, for addition, they are associative. For subtraction, they are not. For multiplication, yes, they are. And for division, they are not associative. Whole numbers, they are for addition, yes, they are. For subtraction, they are not. For multiplication, yes. For division, no. For natural numbers and for addition, yes. For multiplication, yes. and for division, no. So this is the summary of all these properties which we have studied. Now let's do some examples to understand these things, these properties. Now here you can see that we have to add all these numbers. Now there are 4 numbers. So what we have to do, we have to take the LCM to add all these numbers. So here 462 is the LCM for all numbers. So we can write like this, means we have what we have done, we have changed the denominator to 462. Now if we add them, the result is minus 125 upon 462. Now this is the general method. How we are going to apply the properties on these questions? Let's check this. Now we can solve it as this. Here we are taking these 2 numbers and these 2 numbers. So using commutativity and associativity. So first we are solving this because here why we are doing this. Now understand this thing. Here we have taken LCM of all 4 numbers together. Now to take LCM, it is a time consuming and a little bit tough for students to do to take the LCM for larger numbers. Okay, so it comes to be 462, and after this we have to equate the denominators. So in spite of this, what we have done, we know that 7 and 21 LCM is 21, and for 11 and 21, because the LCM would be 22. So what we have done, we have associated these 2 numbers and these 2 numbers, and we had paired them like this. So now it is easy to take LCM and solve the question. So we have added these 2 numbers first and then these 2 numbers. Now to take LCM of these 2 numbers is easy, and solve them is quite more easy as compared to the previous method. So this is how the properties are used. This makes the whole thing easier. Now again let's check this example. Minus 4 upon 5 multiplied by 3 by 7 into 15 by 16 into minus 14 upon 9. So what we have to do, we have to solve this. Again we can use the associativity. The simple method is to simply multiply these 2, then these 2, and we can do this. We can do these like this. It means we are multiplying these 2 numbers, the 4 and then these 2 numbers. Then again we will multiply the results, and the answer is 1 upon 2. It could be done like this also. And look here, minus 14 upon 9, right? Now how to use the properties? Here we can see that these are the multiples of 3, right? So let's check this. If we are taking these 2 together, right? If we are taking these 2 together, then here we can easily see that 15 would be cancelled out by 5 3 times, and 4 will divide 16 by 4 times. The result would be 3 by 4. Now here similarly 7 divided minus 2 and 3 will be cancelled 9 3 times. So minus 2 by 3, and the answer is 1 by 2. Now you can easily compare that in this you have to multiply the larger numbers, and it is time consuming. But here when we cancel out the certain terms and associated 2 terms together to match with them, then it becomes very easy for us. Now the role of 0. 0 is a magical number, you can say. So if we add 0 to any number from either from right hand side or from left hand side, the result remains same. if a is a whole number. If even a, this is a b, or suppose a is a whole number or integer or a rational number, the result always remain unaffected by the addition of 0 either from right hand side or from left hand side. So 0 is called the identity of addition of rational numbers. It is the additive identity of integers, whole numbers as well. So before going to this, what is identity? Additive identity is a number which when added to any number, the result remain unaffected. That means the result remain the same. So here we can see that the 0 is the additive identity for whole numbers, integers and rational numbers too. Now, role of 1. If we multiply 1 from either from right hand side or from left hand side, the result remains same. So 1 is called the multiplicative identity of the rational numbers. Now what you have to do, you have to complete this first question of the exercise, and this is the homework for today.